Welcome everyone, and welcome to episode 2 of the 42 Crunch webinar series on API breaches from the first half of 2022. My name is Mark Dolan, and I will be your host today. I am joined by Colin Domoney, API researcher and developer advocate with 42 Crunch, and also curator of the API security.io newsletter. In episode 1, Colin reviewed some of the major API attacks witnessed this year. And in this episode, Colin will demonstrate how to defend against these common attack types and real-world API exploits. And now let me hand you over to Colin. Thank you.
Thanks very much, Mark, and thank you to everybody taking the time to join on what in the UK is a very, very hot afternoon. I hope the weather's good wherever you are. So as Mark said, second part of this webinar series, we're going to get a little bit more technical this time. And looking at what people could have done to prevent the vulnerabilities that we covered. And just to reiterate what Mark said, questions, this webinar is for your benefit and education. We're happy to take questions. The more questions, the better, because that obviously sharpens the focus. So pop those into the Q&A channel. So let's get started on the presentation. So I was watching the India-England World Cup Commonwealth Games cricket final on Sunday afternoon while I was preparing these slides. And I was looking for a metaphor to understand how making mistakes is human, right? What we're doing in this session, we're not making fun of anybody. We're not deriding or mocking people. Everybody makes mistakes, but they can happen to anybody. The mistakes can be costly. Most importantly, mistakes are a learning opportunity. And here we're going to benefit from other people's their misadventures, shall we say. If we look at that rather humorous little video, I bet that young lady is not going to attempt to just climb over those boards again. There's a couple of other lessons we can take from there. Making a mistake, recovering and getting back on track is most important. She was up in a heartbeat. I got asked this question last time. The question came in on the chat, and the question was, you talk about API security, but you actually spoke about a lot of other things. So I tend to have a holistic approach to how we approach API security. It is focused obviously specifically on the OWASP API security top 10, but there's much, much more to it, right, as we'll see when we go through this. So firstly, we've got API abuse cases. So it's not only about the vulnerabilities and the hacks, it's also people using your API in an unexpected way. People mining information. Let's take an example, a real estate agent website. If people can go and scrape that constantly and pull all the prices off, they can kind of manipulate the market. Right? That's not necessarily an attack, but it's not something that you're expecting to happen. Right? So be aware of these abuse cases. Business logic vulnerabilities, these are things that kind of transcend those lower level implementation vulnerabilities in the top 10. API governance and API inventory, right? If you're not running a sound practice on top of your API process, you're going to have problems. The lower level coding skills, your lack of skills in developers, when we see that in most of the vulnerabilities that we cover. And secret management's hygiene, and also people using vulnerable components and operating system vulnerabilities. The way we think about this at 42 Crunch is we realize that it's a the problem space is multi-layered. You need to start with DevOps. If you've got a good DevOps process, you can produce repeatable builds of your software. Your time to recovery, your time to repair is much quicker. By all means, get your SaaS, DAST, SCA working there. That's also important. But you need an API security platform, and you need a governance process on top of that. We cover what those look like as we move through this session. So we're in the process of rolling out an API maturity model, right, to help people on their way toward a mature API security practice. And what I've done in this is I've come up with what I call the 6 domains of API security. Right, and that starts with inventory. So if I look at that rather polychromatic diagram on the left, that's our DevSecOps cycle. And we're sick of seeing that thing. I've overlaid the 6 API security domains on top of that. So if we take inventory, You've got runtime inventory, you've got static inventory. API design is obviously during your plan stage. API development, that's about your code and build stage. Testing, protection, and governance, right? These are all essential. Governance is the sort of outlier there. That is over the entire process, right? So this is the framework that I'm going to use to frame the discussion that we have on that. So each of those domains in their own right are important. And I think what will be important to each individual is sort of where they are on their maturity journey. And that brings us to question 1, the polling question. I'm just going to talk through this. Mark will pop it up on the screen. So of those 6 domains, which one is the one that you are most challenged with? Which one causes you the most problems? Whether that's fixing issues or getting skills in that space. Which one of those 6 is the most troublesome to you? Okay, so interesting answers there. So API protection scoring the highest, and that's not altogether unsurprising, and inventory, another problem for people. That's not at all surprising to me. Inventory seems to be the one that keeps coming up. Good, we're going to demo, we're going to look at protection later on, so perfect. So let's get moving. Let me recap now. What I'm going to do here is I'm going to refresh over the vulnerabilities that we looked at, but I'm going to go very quickly. Doesn't matter if you didn't, if you weren't in the first session, I'll catch you up quickly. And we'll have a look. So first one was the global shipping company. Now, basically what these guys did, you can read the detail there, but that picture's worth 1,000 words. They had a website that could take a parcel ID and they would return you a map. And what the attacker did was they discovered they could find the postcode from the map, but the combination of the parcel ID and the postcode location, they could get the full access to the full record dump. And unfortunately, they also returned a load of PII over the API. So a couple of things going wrong there. So now I'm framing the discussion of how to remediate and how to prevent this around those 6 domains. So design. So firstly, they didn't understand their PII requirements, right? They should never have been exposing PII customer details over the API. In that circumstance, they failed to understand that an attacker didn't need to have a parcel number. They could fake the parcel numbers, right? The parcel numbers are relatively, we all know these things, they're standard patterns, and that's exactly what the attacker did. And because that endpoint wasn't rate limited, they didn't realize that the attacker could just guess and move through these. And also they somewhat relied on obscurity. And so that map image that they returned, they assumed that it was obfuscated sufficiently. But if anybody in the UK audience, if you have a couple of streets, you can use websites to go and get the postcode, and you only have to guess a couple of postcodes. So relying on a bit of security by obscurity. Testing, they should have known, they should have seen that they're actually leaking customer information over that API. It'd be easy to test. They would have seen that coming back. There should have been a trigger there saying, that's not acceptable, right? Block the release. The protection, we look at rate limiting later. Dead easy thing to do, right? Any API, you can put rate limiting on that. I actually just posted this week in the newsletter. There's a almost seminal piece. I'm going to go and try and find it in a moment on everything you want to know about rate limiting. Give me at the end when we're doing Q&A, I'll go and find that and post it. Campus access control, right? This one was this was a bit of a special one. So basically, there was a campus control app, a smart app on a phone. The developer decided he'd hack the API so that he could write his own app to open his dormitory door. What happened is he discovered he could, by guessing other people, but he didn't have to guess. He knew other students' IDs. He knew their email addresses. And he found that he could just access their accounts as well, and he could fake door locations. So basically, he made himself a digital master key. A whole lot of wrong with this. The design. So firstly, if they'd done a proper design on that, they'd have worked out that the endpoint that's taking location details is obviously open to being faked. They can spoof that. They should have verified the location on the device rather than accepting what came over the API, right? So bit of a design failure there, and they relied on information that was in the public domain and could be guessed. They had Bowler broken object level authorization, the hardest of the API top 10 vulnerabilities to cover. It looks like the developers weren't really aware of this. There's a lot that's been written on this. There's a lot of robust techniques. We cover it on the APIsecurity.io website. We've got how-to guides. This is a difficult problem to solve, but it's a well-understood problem, and there are patterns for how to get it right. But it comes down to developer training and developer awareness. Testing, detecting broken authentication during the test phase is trivial, right? You just literally don't have to do anything. You just try and call the API and see if it responds with a success code. It's that easy. And governance, so these guys didn't have any process. They took the ostrich approach, head in sand. They didn't even acknowledge the flaw, and then just said, yeah, that's been dealt with internally. And they didn't disclose if anybody's been affected. So they should have a governance process in place. What do you do when something goes wrong? This is a goodie. This is the microbrewery application that used hard-coded tokens in the application binary. So of course, any sensible pen tester can go and find those. Let's just have a look at the pictures there. So we can see that, they had a production staging and development tokens embedded, and it was easy to reverse engineer those. And of course, because they were hard coded in the application, it meant that if you knew somebody else's customer ID or their identifier, you already had their token, because everybody had the same token. So you just had to iterate through the IDs, which they could do, and then they were able to access other people's accounts. So I put Hanlon's razor in there. That is slightly unfair of me. I don't like that word stupidity. That's exactly what I said we weren't going to be doing, but I might make an exception here. It's just so much wrong there, right? I mean, letting everybody use the same key or the same token is just, an absolute total fail. This is why we have things like OAuth. That's why we have these frameworks. Use those. And also, let's just have a look at that. Also, they were exposing way too much information again over that API. Hard-coded tokens, right? So testing, and this kind of raises the question to me. That's why I took that fairly hardline view on this. Is hard-coded tokens can be detected trivially, right? It's one of the simplest things that you can do. In source code, you can detect them in binary. So the kind of question in my mind is, did they even try? Did they just say, well, nobody will notice and ship it, or what happened there? So, and that's why I think they failed on their governance. They didn't handle the disclosure properly. It took them ages to remediate it. And then the other question around governance, and this may be more on protection, is they don't know if anybody actually accessed or abused that vulnerability. Actually, one of the things was that you could do with that API is you could get beer discount tokens. So hopefully the security researchers made good use of that facility while they were waiting for the thing to be remediated. That's what I would have tested with. The cryptocurrency portals. So this is a great one. This is the biggest issue that we've covered. It's also pure hardcore bowler, and about as bad as you could have possibly got. Crypto platform, the researcher found that if you had two currency accounts, you could switch the source currency midway through a transaction. So you put some money in one account, initiated the transaction, and when you were about to buy, you switched to the account that had no money, and it allowed you to trade. So basically, you could buy as much cryptocurrency as you wanted with no money. So that's Bowler in a nutshell. It won the research at $250,000. So I put this, I would bucket this under the stuff happens category. This is unfortunate. It's kind of one of these things. They did very little wrong. In fact, they remediated this within hours. They responded to the user pinging them on Twitter. They got into it. They resolved it. They had a number of compensating controls in. They had lots of circuit breakers on the purchase mechanisms. They were looking for price fluctuations and variations. So they would have caught it. But, that's Bowler for you. threat modeling could have identified that attack vector, obviously, if the developers had been more aware of this. And the one I'd call out here, and it'll be more, we talk about this a couple of times. So when you're doing code reviews, manual code reviews are time intensive. They take a long time to do. People don't like doing them, right? Because it feels like you reviewing somebody else's homework, and people tend to resist that. Now, that API endpoint that did that transaction, that's absolute mission critical code, right? So they could have flagged that particular piece of code and said, this is high risk. If anybody ever changes that, we have to get that reviewed by an expert panel. They could have prevented that. But other than that, not a whole lot you can pull them up on. There's certainly the response and their compensating controls were pretty much top notch. This is the best, absolutely the funniest post we've had on the newsletter. Reread it today. It's brilliant. A whole load of, let me just move through to a couple of the problems here visually. We had excessive information exposure. They were leaking the location to almost 10 digits of precision. And if you've done any kind of geometry or map work, you know that you can use 3 different locations to triangulate, trilateration. So they worked out that they could identify the user location. So I like that little quote. These things that use location, they're always going to be vulnerable. I think that design stage, if they'd threat modeled, if they'd thought about how that precise geolocation could have been abused, right, that's they would have discovered that they were open to abuse. If they just got a decent guy who knew a bit of geometry, they could, or trigonometry, they could have they could work that out. There were other litany of things that they had wrong. They relied on client-side protection. They allowed people, what did the attacker do? He was able to find other user IDs by just looking at through the JavaScript. They try to hide some of the authentication in client-side JavaScript. They also had Bola. They also exposed excessive information. Again, easy to test, easy to prevent, and easy to protect against as well, right? So, a lot of things. And one of the good examples of where, one problem leads to another, and allows a skilled attacker. And let's face it, most of them are going to be skilled to attack. WordPress plugin, these come up frequently. I'm just going to move to the explanation. I should have put the code sample. I realized I didn't. Slightly tongue-in-cheek dig at PHP. It's hard to read. I mean, I looked at the example. So the vulnerability here was the plugin adopts the standard WordPress plugin framework. One of the critical handlers that you've got to implement as a plugin is the thing that checks your authorization. So what permissions do you have? And they had a bug in that authorization script or the function. And what they did is 2 things. They got a case sensitive compare wrong and allowed attacker just to mess that up. They hit an exception and they hit the default handler. And unfortunately that returned authenticated instead of unauthenticated. So they chose the wrong default. Now it took a while to read through and review that code. But those functions, that's another great example of a function that is mission critical, right? Anybody who writes that or changes that code needs to be reviewed every time people do that. So I'm not really digging at PHP. It's just difficult it was quite difficult to review that code, right? And that's actually why the mistake was made in the first place. This is another one of these where the researcher found, I mean, he literally found it like he was doing a top 10 greatest hits. He found almost one of everything in that. My view here is they should have, taken this thing offline and redeveloped that. There were just that many problems with it, right? So there was no standard authorization framework. They used guessable user IDs. There was no basic API security issues. They got the job token validation wrong. No excuse for that. They're standard libraries. Just use the standard library, get it right. There's a multitude of guides. We've got guides on 42 Crunch. For good measure, they committed all their keys and tokens to the source code repo. I doubt they tested this, at all. It just looked like they just shipped something Their whole practice looked wrong, what they were doing, and then they refused to acknowledge this. The 5 stages of grief. They refused to acknowledge this. They didn't disclose the issue. They didn't respond to the search, and the portal or whatever it was just taken offline. So lots of badness. Load balancer. When we talk about embedded systems, these things are quite reliant on APIs to interconnect with other systems and backends. And what this issue was this was a management portal that exposed, I think this was a code injection. And what happened here is there was an API endpoint that had a web interface and had an API interface, and the researcher worked out that he could access that, and he had a session token, and that worked. You removed the session token, and it still worked. Right, so straight up broken authentication, none. Right, so let's start with governance. So on a piece of equipment like this, and you might guess who the vendor is, there's no way that should ever been released to production. Right, such an obvious thing to have got wrong. They really needed to govern that process. And again, comes to couple that with testing. They should have been able to easily identify that and get it stopped. Development, again, that question of code review. If anything can run a command shell, then you probably want to review access to that. I'm not suggesting that you review 1 million lines of code. You don't have to. You have to review the 500 that are important. And in a design stage, this is again a bad choice of default. So they enable that diagnostic service or that command port, rather disable those and just make it easy to go and turn it on. Why would you not do that? That's the obvious defensive way to think about it. We've almost exactly the same nature of vulnerability here. We've got a home router. This is one of these little cheap things that you buy. These things are normally running some kind of Linux-based kernel. And normally these things come with insecure defaults as well. They maybe come with vulnerable versions of the kernel and the like. The issue here was we had, let me just find the screen. Yeah, there we go. So on that screen, we've got it's very typical ping test. They're trying to be helpful. They give you this UI. You go ping that. If you look over on the right in the Postman window, let me just see if I've got the cursor going. That's the post, that's the endpoint to the Common Gateway interface. They hit that point. They discovered there was, again, this is an issue somewhere here, there was a session token. And what they discovered was it didn't need the session token, right, in the first place. And then they discovered they could manipulate command injection so that let's go over there, where we're doing ping ;ls, that's just OS command manipulation. It'll execute the ping command on nothing. So that's why you've got nothing as a ping result. And then it does an ls. Right? So that's straight up command injection. Can be prevented in source code level. You can protect against command injection, but they simply shouldn't have allowed that endpoint to have been called without authentication. That would have been enough to stop it. Right. So pretty typical of these type of issues. And again, because they're developing an embedded system, it's very hard to do patch and release and update this. So the way to solve this is make sure you get it right. Make sure you don't have these type of vulnerabilities kind of up front. Again, testing unauthenticated endpoints, easy to discover. Development, again, we could have code reviewed that, right? Simple thing. And then also just some basic awareness, such an obvious thing to be able to fix, and then also disable that thing by default if you don't need it. Smart scale. So I said we're not going to do super technical in this review. We're hoping to be able to present a webinar on API hacking. I'm working with a couple of people trying to put together a session on that and just show you how smart API pen testers and what they can do. Now, this is a really, really good example of where a couple of relatively benign issues were chained and coupled together, and gave the attacker complete system control. They could take over the accounts and platform, right? So, beware of this. The issue is often not the individual issue that's found, but it's the way that a skilled attacker can chain them together. And this is also worth a read. I think it's in a relatively recent. If you just search APIsecurity.io smart scale, you'll find that. So just a couple of examples. So on the left there, we've got an issue where we disclose the access token over the API. And then for good measure, we also disclose the refresh token, right, which is, basically that's giving you perpetual access to the platform. And here we had a pin reset. You could call an API to reset your password. They didn't have rate limiting on that. They also used a guessable ID pattern. So the attacker could attack that, right? So a couple of things wrong on that. They got things wrong in the design stage. Very definitely, they used insecure. That's copy paste. They used guessable IDs and pins, right? So the threat model would have caught that, make those things random, vary them around. Development pretty lack of basic. They allowed things like you could steal the session token from the UI and use that on the API. These things are simple. Couple hours of security training would get that solved. Protection, again, excessive information disclosure, where they leaked too much information there. They leaked not only PI, but they leaked the refresh token, which is basically nulling their authorization or the authentication method. Testing, dead easy to go and find a leakage of tokens and information. Rate limiting, they abused that password reset function, easy to fix with rate limiting. Governance, they were appalling in the way they responded, and they were very slow to get back to the researcher as well, right? So, and probably no coincidence, you see a pattern emerging here. The people who have the most egregious and most, poor API security posture tend also to be the ones that have the least proactive governance and response process. Automation platform, this was another embedded system that allowed industrial control. And again, it was an RCE, remote coded execution attack, and also resulting from broken authentication. Pretty simple thing here. And again, code reviews and being able to test that. And again, that comment on strong governance on something that is going to exist for some time. Make sure that you're governing that process. CI/CD platform, who shall remain relatively nameless. It's a slightly perplexing one. This was a case where the researchers discovered that if they could guess a number of slightly random API endpoints, they could ultimately go, and that's a picture with that, they could ultimately go and retrieve a load of access logs, which then had various tokens from third parties, so things like AWS, Docker, all the usual third-party platforms that they integrated with. And they could expose these all via the API. So let's go on to the assessment. This is pretty broad-reaching. So design, they had these API endpoints which weren't documented, but obviously existed. So that's a bit of a no-no. So that's security by obscurity. These things, I throw can't run or REST that'll find that in no time flat. That'll find those endpoints. They also didn't correctly mask or obscure the credentials. So in some cases, I can't remember which one it was, but for one platform like Azure, they masked them correctly. And then for AWS, they didn't mask them at all, which kind of indicates that's a bit of a code smell. That's pointing at the fact that they probably don't have a standard methodology for doing that. And maybe they have different teams working on different parts of the platform. So it looks a bit like a bit of poor governance, a bit of poor development practice on that. Protection rate limiting. So what the researchers did is trying to guess those endpoints. They brute forced by sequencing through. They could have protected that with rate limiting, and they would have taken that whole attack vector away. And they also practiced pretty poor data retention and sanitization. So they didn't mask the data when committing to storage. And also they didn't seem to have a method of erasing this. And actually when challenged on this, they said, well, it's all just a feature. there's no need to do anything, much to the understandable horror of the third parties concerned. So also not great. And as far as I know, and we won't paste the link to this in here, but you can go and find it. This thing is still existing. It's still out there, despite having numerous security researchers calling them out on this. So how to avoid featuring in the next issue of this webinar, which we will now hopefully be doing quarterly. How do you prevent some of these issues? So we've covered at a broader level on these. I'm just going to call out things that for me stood out, and this is where please fire away your questions on this, because this is my opinion of how we can get better, how we could have certainly solved some of these issues. So in a lot of cases here, my opinion is people just didn't think about things. And let me just caveat that slightly. I'm not accusing anybody of being neglectful or stupid, but when you're developing something and you're in the zone and you're solving your own problem, exactly the wrong person to be reviewing this is you. Get somebody else to come and have a look. Do a sanity check, right? So have security experts that come in, and that example of the mapping information where the high precision of geolocation. Anybody with a bit of perspective on geolocation would have known that that's an issue, right? So threat model that understand your attack surface. So example of the attack surface is the enabled debug and admin ports. The first threat model be what are your interfaces? Why are they enabled? Solved. Mitigations and compensating controls. So the example of the cryptocurrency portal, they did a really good job there. They while they didn't perfect nailed implementation of that method, the function doing the trade, and they certainly had a load of compensating controls in place. Right. So threat modeling is fun. It's a good way to get the team involved and get people thinking about security. We at 42 Crunch are firm believers in threat modeling for APIs, and we're hoping to be working in the next couple of months with one of the luminaries in the field of threat modeling, and we're going to talk about specific considerations around API threat modeling. So hopefully we get that sorted out. Keep an eye on the website and the newsletter. So SEMGREP, how many times we had hard-coded tokens, we had credentials committed to repos, we had missing authentication, all of those kind of things. There's an example of SEMGREP. So I'll show you what SEMGREP is doing. So SEMGREP, conceptually simple thing. It's a semantic grep. So it's a high-powered, high-speed grep with a bunch of rule sets that can look for semantic issues. So here we're detecting a generic API key. So there's a bit of regex awfulness there that finds a key, and there's the metadata. So they're matching it against a set, and they're able to detect things like keys, right? And that you can get. SEMGREP is free. There's a paid version. These type of things to run that, put that in a CI/CD pipeline when your GitHub actions are trivial to do, right? They can find a load of things as well. Hard-coded secrets, missing authentication and authorization decorators in your source code, JOT token validation errors, so they can go and find if you ever checking the signatures in your JOT, misconfiguration of transport. There's a load of things that you can do with SEMGREP and that are almost free, right? So there's a real low barrier to entry there. Few times we saw excessive information exposure. Now, this telltale sign of what's happening underneath the hood there is people are using object relational mappers. So these are, for people who are not database geeks, the ORM is a code layer that sits between the application and the database. And what it does is it makes it very easy for the developer to use the database. They don't have to go and, heaven forbid, write any SQL. They just call an object as if it were a live data, and then the ORM maps that back to the database. So they're great. They really help developers develop quicker. They reduce mistakes. The problem is it makes it much too easy for the developer to inadvertently expose the entire data object. So let's just take a customer account field in a database, that's probably got his home address, his mother's maiden name. He's got all of that good stuff in that account record. And then what happens is you want to retrieve his, let's take that example of the parcel shipping thing. You just want to retrieve his approximate address. So you're looking for a postcode to half a mile resolution. But instead, when you call the API, it returns literally everything they have on that customer. Right. And of course, your attacker is sitting there with the web tools or with the proxy, and they just read that all off the API. And that's probably happened, not always the case, because the developers haven't thought about their threat model. Right. They haven't considered that API. In the mind, they're thinking, well, it'll only be used by the app, and the app knows what to do. Right. So it knows not to show all that information, but they don't realize that that information's out there. Right. So the ORM, be wary of that. And also, this is another thing that is quite easy to detect with grepping through code. The telltale signs of an ORM in code, pretty obvious. And if that thing is also connected to an API, you can flag that function for code review. So all easy. I'm not saying don't use ORMs, but realize that they make it easy to make mistakes. What we saw an example of JOT token validation where they got that wrong. No excuse for doing that. Authorization BOLA. So one of the best ways to protect against BOLA, use a proper authorization framework. So we've got OSO, we've got OAuth in there. Use these things. Don't go and invent those examples of people embedding tokens or doing some obscure things with tokens. That's why we have OAuth, right? We've learned these lessons the hard way, and we've got standard frameworks and standard ways to solve these problems. 42 crunch. I nearly forgot I've got a demo to do. 42 crunch, shift left, shield right. So just briefly, what we do, we have 3 product categories. We have API audit, which helps you build those contracts correctly. So I saw a couple of people raising the issue of design time problems. When you're developing your open API spec, audit it to make sure that you're constructing that thing as completely as you can. Testing. So a number of times we identify testing. We have a conformance scanner that makes sure your API is behaving exactly as it should and not doing anything else. That type of testing would have caught a high number of these vulnerabilities. And then the protection is what we're going to look at in a moment. Those things like rate limiting and excessive data exposure, those are things that are super easy to catch with a runtime protection. I'm going to do a relatively simple demo. So what I have here, I'm just going to check that it's set up correctly. So I have a little application running locally, little Node.js. What I have here is I am currently accessing the raw API. I'm not going through our firewall. So what I'm going to do is I'm just going to log in and see that that's working. So I've logged in, I've got a token. I'm going to do a couple of things. We're able to access that API. It's behaving as expected. Let's do some things that are where it doesn't do the right thing. So here we've got an example where we're returning too much information. So we've done a get users list, and we've seen that we are returning a password, right? So what's that? That's excessive data exposure. So that's bad. We have mass assignment, where the attacker can go and guess fields. And again, this is where the object relational mapper is a problem, because they guess that there's a field called is admin. They send that and it says it's updated the record. And if that field actually existed, it would have written that to the database, right? So problem there. And then the other thing I want to demonstrate is we've got, I'm just hammering away at that as fast as I can. You can see that, I can abuse that. There's no rate limiting on that. So without doing a single thing on the back end, just to keep myself honest, I'll switch the URL. I'm still connecting to the same app, but now I'm connecting via our firewall. Right, so we'll just remember to save that. And what I'll do is I'll just log in again, check that. Right. Okay, so we've got a new token, we've got a new session. We'll go and get the user information. What I'll show you here is I'll show rate limiting on this. 3, 4, 5, 6, and there we go. So we've rate limited on that. We've got a 429, too many requests. Right, it's dead easy to do. It's a couple of lines with 42 crunch protection in the Open API specification. Easy for the firewall to implement that. Let's see if that's should have timed out. Yep, so it's reset. We've got this get users list now. And get all users. So what's happening here is the Open API spec has not included that password field. And what's happened is the APIs try to return more data than it should have, right? So what the firewall does is it just says, right, I'm blocking that. Right, much better to have it block and break the application than to return the information. And then, of course, you can go and trap that error and find out why the API is now suddenly doing something it shouldn't. And that mass assignment example, I'll do that again. I get blocked, right? And then what I'll do is I'll show you the mass assignment does work. Where I've removed that injected field, we can do that, and that now works, right? So that's all being done entirely automatically in the firewall, but I haven't had to change important things here. I never had to change the backend code. I never had to, change anything there or change the implementation. What I can do is I can just do that in the firewall. Right, so on that note, that brings to conclusion the demonstration and the walkthrough. So I do hope that was useful. We're going to ask another question now. If you could just vote on that, just promote that. So what are the main issues? So, right, improved API security testing and automated scanning of API code. So yeah, I would agree with that. I think we're probably overdue to do something on scanning. So what I'd like to do is with that is show how, those issues that are called out, like excessive information exposure, broken authentication, to show how those things can be identified with scanning. So duly noted. We'll get onto that and cover that in an upcoming session. And learning more. So APIsecurity.io is obviously where I'd recommend to go. We cover the API security space every day. We are vendor neutral on there. We cover industry news. It's a learning resource, and it's there for your benefit. So just grab that QR code if you're not a subscriber. If you are a subscriber, I'm going to apologize now. This week's issue will be a day late, but it'll happen. And the other thing is Corey Ball, API security researcher, frequent contributor to the newsletter as well. He's just got his book out. If anybody's not aware of that, go and get that. Highly recommended. It's an offensive mindset, hacking APIs. Quick read and loads of useful information in there. And he goes into a lot more detail of the type of advanced attacks that we do. Okay, so Julia, I'll answer your question about the opinion of auto generation of open API specs from code. This is something we're going to cover. We're actually talking about this internally at the moment. Is this kind of a round trip between specification and code. So the auto generation of open API specs, it depends a little bit on the framework or the language that you're using. Java, very mature. The Swagger support for that. .NET is good as well. There's multiple providers for .NET. Python is pretty decent. Generally, these things work well. The reason they mature and they work well is because a lot of API developers depend on the Swagger UI as their documentation, right? So they want to make sure that Swagger spec is working and documented, and often have that Swagger the Swagger interface. So generally that works well. There's always, with these things, there's always going to be corner cases and things that don't work. I'm also interested in the other round trip. So really, being able to take that spec and actually make code from that, because that's what we want to avoid, is people having to translate the code by hand from the spec. So I am interested in opinions on how well Swagger code gen is working for you and what people are doing with that, because I'm not sure I'm absolutely thrilled with the kind of results that I see. And it is a little bit difficult to get that integrated into some of the frameworks. this is something 42 Crunch as a community project are going to start working on, is having much more detailed write-ups on how to actually implement the API code and the backends. So hopefully that's answered that question, probably more than you strictly needed. Let's answer that live. Done. So what do you want to know more about? Feel free to answer that in the poll, or just chuck questions in the chat. I'm very happy to take those as well. Right, so future webinar topics. What do we got there? API hacking tools and techniques. So great. So we are, as I said, currently working with a couple of pen testers and security researchers to get them to come on and as a guest slot on a webinar and show us what they do, right? Because there's nothing as powerful as the visual demonstration of the skills, right? And as a takeaway, you know, have an appreciation for what these people are able to do. You know, you really have to, and that's why the threat modeling is so important. You know, think like an adversary. So definitely do that. Defensive coding best practices, auth-in. Yep, that's all on the cards. And I took the note about the security testing. So that concludes the session today. Keep an eye on the website. We've got more coming up on the webinars, and we have a bunch of activities. So the newsletter is coming up. We've got the Open API editor free tools. We also have 3 sponsored events in the US at the DevOps Days, Dallas, Charlotte, and Chicago in the next 2 months. We have the ASC Applications Specifications Conference coming up in San Francisco. Isabel Morney, our co-founder, will be there presenting on that. We'll also be running a workshop. And then I'm over in San Jose, in California, at the end in October, and I'll be presenting at API World. We'll also be running a training workshop and a presentation there. And we look forward to seeing you on an upcoming 42 Crunch webinar. Thank you very much.